Hi guys, welcome back to Learning Electronics Repair. Paul's still here, he goes back to the airport today on his way back to sunny England.
Yep.
Sunny but cold, probably. So I have a laptop here. I will say straight away, this is not a Bang & Olufsen laptop, it's a HP laptop. It only has Bang & Olufsen speakers. As somebody corrected me last time, I said I had a Bang & Olufsen laptop, and they said you don't. I learned, see? So I learned the lesson. So this came from Handy Andy. He says it switches on but doesn't boot. I think that's what he says. And he brought it to me like this. So there's no battery fitted. He said the battery's no good. No power supply with it. I think the hard drive is under here. There's no hard drive here, but I think this has a M2 or something under here. Or he tells me it does. And it's, what does it take for power? Oh, it has a little round socket. So what I'm going to do is, I'll take a connector, plug it into here, okay? And I'm going to connect it to my bench power supply. And I said that to you because what we can do is then, when the bench power supply powers up, we can see what this is doing, how much power it's drawing. And that gives us some idea if there's a short in here or somewhere, or if it's just not starting, so it doesn't draw much power, yeah? So let's get some cables. So, of course, as is sodding typical, it has like a connector. Looks like it has a small pin in the middle. And in my box full of connectors, a whole box full of various connects I use to connect things, I haven't got one of those. It might have been one of these, but there's one missing, and it was probably the one that was missing. So what I think I'll do is I'll actually take the connector off and see where it wires. It comes down here. In fact, I might even leave it on, just figure where it's going to, and then solder a couple of wires on here, and I will connect to my bench power supply. So let's see where it goes. So it must be, I mean, it's under this thing, but I see a wire down here, but I need to take this off, I think, to make sure. Oh, there's some more wires there. I'll take this off. So chatting with Paul here, we've decided that it's this cable, yeah. Comes here, and that goes, I think it goes to there, but that actually might go to the speaker. I'm pretty sure, would you agree these are speakers?
I don't know, no, I don't know what the layout is.
Well, I'm gonna take these out. So I think these are speakers. So you'll be able to fix laptops when we finish this, mate.
Yeah.
We may have another one to look at as well, guys. So today's one of those days I have a few little jobs. So just flick the thing up. This is holding this down. If I knew these laptops, I'd know where that wire went, but at the end of the day, you want to make sure you connect it to the right place, yeah? Right, so that definitely goes to the speakers, and now I can see this is the power. Okay, so we have multiple wires. I'm thinking this has like a sense pin. This is it, I think this is ground and power. Yeah, see that there? That's a protection diode, so this will be reversed across here. So if you connect the power backwards, so this end is the positive, I think this must break down. Or the power comes in here and flows through here. So if you connect the polarity here wrong, that diode is reverse biased, yeah, and then it doesn't flow through there. So that's like a reverse polarity protection, and we can just check that. Okay guys, so with this little connector I have to plug it out a little bit to reach where the connections are here. These must be the plus and minus, and we can prove this. So the black one will go to ground, which obviously we have a stud over here. Okay, at ground, so that's ground, and this one here, the pair of them, go to here. So this is positive, okay? That's your first MOSFET, so it has to go through the MOSFET to power the 19 volts in, and then this will go through the second MOSFET, and then it will generate all of the voltages. So this also goes to here. And if you look at the diode, this one, and it is a diode, we can measure it. So positive on the anode, cathode, the diode conducts. But normally this end would be positive, so the diode doesn't conduct. What this is there for is if you accidentally manage somehow to connect the power the wrong way round. So what would happen then is the positive would be going to ground, which is this end of the diode, and the other end of the diode would be going to the negative. Yeah, wrong way round.
It's just short, wouldn't it?
It would short. Yeah, so it would just short. That's why it's a big diode, so it won't blow up. It will short the power supply out and shut the power supply down. So what we can do is we can solder on either end of this diode. Actually, it's probably a very good place. We put the plus and minus on here, and then let's see what the thing does when we power it from the bench power supply. I've tagged a couple of wires on then, you can see. So we can power this up from the bench power supply. Let's see what it actually does. So first of all, just need to set the thing to the right voltage, of course. So I've unplugged the laptop. Just get the voltage set first. Okay. Close enough to me, that is. Right, okay. Now we can plug it in and let's see what it does.
Turn it around, turn it over as well. Power it up.
Well, let's have a look. So it just sits there drawing 10 milliamps, 20 milliamps, so it's in standby basically. I'll just turn it over. I'll switch this off in case these try to short or something. Okay, so let's see again. So power supply, 10 milliamps, try and power it up. Which is on the side. So it doesn't power up. He said it powers up. It doesn't power up. In fact, it's gone to 0. Interesting. So it doesn't power up, that's for sure. Okay. I'll just disconnect the power and reconnect it. We're back to 10 milliamps. 20 milliamps. I say there's no short, at least there's not a short at the 19 volts.
Blinking on the side.
Oh, okay. Ah, this is probably what the guy means. So, thank you, Paul. There's a LED on here, but it doesn't start. That's what he means. So the LED is on, which is saying power, I would say, but it doesn't start. Okay. And in fact, when I press that, it actually goes down to 0, which is interesting because the LED is still on. But bear in mind, the current meter here will only read down to 10 milliamps, so it's probably just drawing a bit less than that. Okay, let's see what we can figure out. So what I'm going to do, guys, I'm going to actually check from all of these inductor coils to ground. So each one of these will be a voltage rail. When I say each one, you might find that some voltage rails have 2 of them, like 2 phases or more. For example, the processor probably has more than 1 phase. And I'm expecting probably what I'm going to find on this is I've got standby, so 5 and or 3.3, possibly both, but nothing else. That's what I think I will find. So I'm going to connect to ground. Power supply is back on, so it's drawing that 10 milliamps. Okay, 20 milliamps. So what do we find? So we just go on all the coils. Well, that's 0. Another one here. That is 8.8 volts. So I do have some voltage. 10. Right, this one here is close to the battery connector. So it's a very good assumption that this is the battery charge circuit. And obviously there's no battery fitted. We can go on to 10.6 now. So we can't charge the battery. So that's almost certainly the battery charge connector. That one was 0. This one. Nothing. Nothing. So this is not running. This one. Nothing. Nothing. And these two. Nothing. And nothing. Okay, so I don't see anything apart from the battery charge circuit. In fact, this has gone to 0 again. And there's one here. Just get to this one. Nothing. I'd expect to see a 3.3 somewhere. And I'm not doing. I mean, there may be some more under here. Or there might be some on the other side of the board. Well, if there's no 3.3, there's no standby. That means the thing can't boot. Because the EC chip, which controls the boot, needs power.
Yeah.
So we would have to have a standby for this to start. Okay, let's see if we can investigate it a bit further. Okay, so there's a couple of things we can test here, guys. The first one is, do we actually have a standby? Because this is the power button. So we can pretty well assume what this is going to do. It's going to have a 3.3 or a 5 volt on it. One end of the button is connecting to ground, one end is a signal, and when we push this button, it shorts that to ground. It's not really shorting the 5 or 3.3 because it's coming through a resistor, a pull-up resistor. So when you push the button, it'll pull it down to ground, and that's what signals to the EC chip to start all the power supplies, to start booting. So I can see there's 2 pins here, which don't connect to each other, but if I press the button, they do connect. Again. So the button's okay. And then one end of these will go to the ground. This is probably ground, or here. Yeah, this is ground. So that end of it is ground. This end isn't ground, and when we push the button, it grounds. So what we must have for this to start up is a voltage on here. Probably 3.3 or 5. So let's power it up again and let's see what we've got. So, power on. Ground. What's on here? Nothing. There's no voltage on the button. This can't start because the standby isn't running. That's my guess. No voltage there. Yep. So guys, I would say this can't start because the standby supply isn't running. So what we're going to do now is we'll have a look from all of these coils to ground to see if there's a short. So if there's a short on the standby voltage, that's why there's no standby voltage. Now, you might think, oh, well, if there's a short on 3.3, this will be sticking lots of current into here. But bear in mind that voltage is generated from a buck converter. So it may just be that the buck converter doesn't run. That's why we don't see a lot of power. I mean, it may well not be this. Another idea we can try is the connections to here come from this connector. So we should be able to check on these pins. And if we see a 3.3 here, but not there, we have a problem with this ribbon. Yeah, so that's another reason why it wouldn't start. Try reseating it. But first of all, let's just check for shorts. So we go into continuity mode is fine. Meter is working. And we'll measure the resistance. Actually, I'll go into ohms range because the resistance will give us a good idea what we have. So this one is well into the kilo ohms. This one, capacitor's charging somewhere, but it's tens of kilo ohms. This one, 83 ohms. That might be a RAM supply or something like that. That's fairly typical for RAM. Between like 50 and 100 ohms roughly. This one, 4.9. So that's not a short. That would probably be the supply for the CPU. And look, CPU's here. This one, again, 3.4. Just go back to that one. 4.9. One's probably the GPU, one's probably the CPU. This one, 3.3. It's actually in parallel with this. I'm just not, close enough. This meter doesn't read 0. And this one, 16. Seems fine to me. That's probably the PCH. This one, 42. So these all seem fine to me. So there's no shorts there that I can see. But again, I don't know where the 3.3 or 5 volt standby is coming from. I might find a schematic for this if we're lucky. Let's have a look. So, well, we know where the connection is on the power button. It's here. So if we measure from here to here, we should see continuity on one of them. Yeah. So let's have a look. Probably the end pin, wouldn't be surprised. And we don't. Oh, hold on, not continuity. It'll probably come through. You know, I said the 3.3 volts here is coming through like a pull-up resistor. So it's not going to short the standby down to ground. It's just going to... I'll draw it. So yeah, basically, we're going to have a standby supply. Standby. I think probably 3.3, but, you know, could be something else, okay? And then we're going to have a resistor to one end of the push switch. Okay, that's the switch. And then this is going to go to ground. So when we push this switch, it just pulls the voltage here down to ground. And this is the power on signal back into the EC chip. It says, oh, somebody's pressed the start button. So we won't see a connection continuity from here to here. If we didn't have that resistor, it'd be shorting that supply. Yeah. So there'll be a resistor. And we should be able to see it, and it should be like a sensible resistor value. 10k or, you know, something that's sensible. So let's have a look again. So we know from here, we know from here, I'm on no resistance range. Let's see. So and I don't see anything. Then you think, is your meter working? Yes, it is. Well, that's interesting because there should be a connection. This is looking like we have a bad ribbon cable.
And check those connections on that.
Yeah.
Check the ribbon.
Yeah, it looks that way. I mean, that's how it's looking to me.
Yeah, well, look, I mean, that's maybe not quite.
Maybe not quite in, exactly. So we reseat this thing.
Oh, I might be wrong.
Well, we reseat it.
No, that looks good.
Yeah, and now we should see again from the switch, from here. There might be a direct connection. The resistor could be on the main board. Nothing. Okay. Let's have a look at it.
Yeah.
Yeah, go on. Yeah.
Where the USB, there's no bent connections or anything in there.
No. And I don't see why that would be connected to the same as a switch. But there might be under here a circuit that does like start up on USB, which does something under here which also connects to the same signal. Maybe. Okay. Okay guys, well, Paul was off the side of the screen there and myself had a little bit of a poke around this, and we have two quite interesting things to tell you. So this is the switch we know about. We know the switch operates and we know that it grounds this pin when you press it, but nothing from this switch connects down to here. Okay, we knew that. So if we look at the switch itself, you can clearly see there's a trace here which goes up here, and it goes to a via there. It does actually connect to there clearly with the microscope. We can see it goes there, which is just the other side of this hole. Okay, and that which is here comes down along down, and that goes to this point, and from this point it goes to this point, and from this point it goes to this pin. Okay, so from here to here we have a connection, okay, to this point here, and then if we follow that to the other side of the board, we can see it goes to this via. In fact, we can even get onto it. Just scratch a little bit, yeah. So there's the via, and then through the via it comes here. I've scraped away a little bit, and we can see that goes to here. Okay, but it doesn't go to the switch. So there's a break somewhere right here. We'll get the microscope. And we can clearly see again, this goes to here, but electrically it doesn't go to there. We don't have a connection to there. But the other interesting thing is that this point is going to ground. So the signal line is shorted out, okay, to ground. That's reading 3.9 ohms. I'll just actually measure the resistance. So the resistance actually reads 4.2 ohms. It's not exactly a short, it's a very low resistance. So I think we have two problems. I think one, we have a break here. We definitely have a break here. We can know that for sure. And we have this low resistance on this signal to ground. That is, I don't think it's connected to where these resistors are. Let's have a look. So from here, just make sure we're on it. Yeah, it's reading like not 0 and 1.2 or something. Does that go to here? No. Can't get a sensible reading out of it. I can't get a sensible reading out of it. Why can't I get a sensible reading out of that? I'm pretty confident this doesn't go to there. I'll just scrape a bit of the shit off it. I'll just clean some of this stuff off, guys. We have like some crap on this. In fact, I think I'll just get the ISO and clean this thing. Okay, guys, so we've got somewhere with this. So basically, if we look at this, we have a power rail here. We have two capacitors, okay, all connected to these pins. Now, this has a USB connector on, so I would say this is the USB supply, probably 5 volts. And these two capacitors, this voltage rail, well, we can see from here, goes visibly to the capacitor. We can see where it goes anyway, and electrically, and the other end of the capacitors connect to ground. So they are just the smoothing capacitors on the 5 volt supply for the USB. And that may well be there all the time, because some of these things will have like start on USB. I mean, on my computer at home, I can charge my phone while the computer's in standby. So that may be there all the time, and maybe the same voltage that actually this triggers. Then we have these two resistors, okay? And you can see that they actually go to the LEDs, this one and this one, okay? From this end of this resistor, goes to the LED. Just get a connection on it, guys. Yeah, goes to the LED. And the other LED goes to that one. Okay, and if you remember, I said one of these reads 130 odd ohms, the other one read very low. And I showed you guys that. So if we go to here now, this one 135 ohms, and this one also 135 ohms. Okay, so that's gone from very low to 135. And if we look from here now, this is where we had the short on the signal for the startup. No longer has a short. Yeah, short's gone. So there was some blob of stuff here, and I think that must have been conductive.
Yeah.
Because we've cleaned it off, and we no longer have a short on that signal. We still have the problem whereby we need to fix the trace that goes to the switch. Okay.
Yeah.
Here. Well, that short has gone. Okay, so let's just fix this, and then we'll see if the laptop works. Well, this didn't prove to be totally simple to repair. As soon as I tried to solder a wire on here, it just took a chunk out of the track. So what I've done is, I've soldered a wire from the switch, and that goes around the board, and then it solders onto the point here. You see, that's where the like little wires were. Okay, so I've done that with it. But it'll fit in, it's okay. It goes into the laptop quite happily. Like so. So that's fine. You can see it goes around this way where there was a gap. So let's see what this is doing now. Power on. And it's drawing 10 milliamps. Oh, look, the LED is flashing on and off. That's without pressing any buttons, okay? What voltage do we have on the switch now? Oh, well, Yeah, we get 3 volts and it goes away again. When the light goes out, we get the 3 volts for an instance. Okay, let's try pressing the switch. So I'm pushing the switch in. It's pushed now. So the switch still isn't actually doing anything. This end. That's ground. 0. Yeah, I'll hold the switch in. So the switch still isn't doing anything. It's doing this strange voltage thing. Let's check the continuity mode. Just check the switch because it was working before. Okay. Yeah, the switch works. Well, that's strange, because if the switch works and it goes to ground, I'll just find a ground point. Yeah, definitely goes to ground. So how can there be a voltage on there? Intermittently. Again. That's without the switch pressed. I'll press the switch. Well, that would suggest that there's... Let's just see. Let's go to ground here. Okay, hold the switch in. Oh, no, the switch... I didn't have a good ground. Okay, look. It now goes to 0. As you would expect it to do, okay? And the LED is still flashing. Okay, so... the switch is functioning. We have, look at that, interesting. What other voltages have we got on this? Let's have a look. So, well, that's 3.3, which is going on and off, but at a different speed. This was only coming on momentarily. This one, 5. Off and then, see, that's doing a similar thing, but that only goes off for an instance. So like more like this is doing, this only comes on for an instance. This one, that's 0, doesn't change. This one practically 0. This one same. This one same. These, I think, are the CPU and PCH or graphics. This one was a battery charger. So what's this doing? 10, 7, 10, 7. This one, oh look, 1, 0. 1, 0. Okay. So what we've got is we've got the 3.3 volts and the 5 volts coming on and going off, but at different intervals, or probably the same interval but at different, like, chemical to duty cycle. Yeah, and that's also doing the same. So these will be controlled by the little controllers next to them. Let's have a look. So these are the 5 volt and 3 volt supplies that are going on and off, marked BACAP and BABAP. So BABAP and BACAP. Yeah. And I can't find anything. I search for these and various combinations of that. They're obviously going to be buck converters with built-in MOSFETs, because we can see they're connecting directly to the coil. So these are clearly what is driving these rails. These will be controlled by the EC, or embedded controller, which is what we used to call it, Super I/O. So basically you'll have an enable on these, and then the EC will switch it on, which said an enable, it will power up. When it sees its voltage is up and running correctly, it will reply back with the power good, and then so on the next one. And we can see that they're not switching on and off at the same time, or rather not in the same order, so the on time and off time is varying. And that means these are being controlled by something when they're switching on and off. It's not like there's a short or something. And anyway, it's drawing between 10 and 20 odd milliamps. It's not drawing much power, so it isn't a short. So because I can't find the data sheet for these, the next thing to look at is the EC and see if I can find a data sheet for that, and maybe we can probe around there. And the EC is here. So it was on the other side of the board. Having got the board out, we can see it. So NE or ENE, then KB9028G. I've had a look. I can't again find a data sheet for this, but to be quite honest, it wouldn't really help me a lot because we can see that this is a BGA chip anyway, so it's not somewhere you can probe the pins, so that wouldn't have helped anyway. I don't see any problem with the PCB. I don't see any corrosion or any other liquid damage or anything like that. It all looks just fine. Okay, just looking around it a little bit. There will be somewhere, I'm confident, another supply to the EC. So I don't think the 3.3 and 5 that are going on and off, either of them are actually powering this chip. I'm sure somewhere on here is going to be a linear regulator, so not something like a buck converter that draws much power. And the linear regulator will supply this with a standby voltage and keep the real-time clock running, for example. So that voltage will be there all the time. Unfortunately, I don't actually know where it is. I don't even have a model number of this. I haven't even got the back for it. The laptop, okay. I probably could go find out, but I'm not sure that would help a great deal, to be quite honest. I think we have enough to go by to make some reasonable conclusions here. Okay, so we know the voltage rails are going on and off in a strange manner, like a controlled manner. So I know we don't have a short anywhere, at least that I can see. A, because we don't have any shorts on the outputs of any of these buck converters. And B, because the power supply was supplying 10, 20 milliamps. And as the thing was switching the on-off thing, it was changing from 10 to 20. Okay, it only has a resolution on the current meter of 10 milliamps, so it could be between 10 and 25 or so. But it's a low current and it's changing as that thing switches. So even at the lower current, this is still drawing something, which basically tells me there is a standby 3.3, and it probably is on all the time. I also think that because these are switching on and off in different ways, if the EC effectively could switch off its own power, it couldn't switch it back on again. You see what I mean? That's the theory, at least. So I think the standby is there. That's why we see the 10 milliamps and a little bit more when it switches these on and off. Okay. And bear in mind the 3.3 and 5 don't actually supply any of the parts of the laptop that draw a lot of current. So I think it is the EC which is doing that. Now the question is, why is the EC doing that? Well, it could be faulty, but I'm not sure that's the case, and I'll give you one reason why. I found a definite fault here, a clear and definite fault, and I have fixed that fault and the behaviour has changed. It's now doing something differently. There's no CMOS battery on here, so I can't clear the EC. The EC is a programmable device. I'll come to that in a moment. But the reason why the EC is doing that, yes, could be faulty. B, could be corrupt, like a corrupted BIOS. So EC is embedded controller. That's what it stands for. It's a microcontroller itself. So it's running a program which is managing the motherboard, all the power rails and reset signals, and effectively booting it up. Okay, talks to the keyboard and a few other things as well. So faulty EC, corrupted EC. Now it could just be that it won't power up unless it sees the battery. So I went up to see Handy Andy and I asked him, do you have the battery for this? He says, no, when it came in the battery was all bulged and it's 3 volts. I said, have you ever seen this working without the battery? He says, no. So it is possible it won't work without the battery. And no easy way to prove that unless one of you guys knows. Another thought is that the power lead, which we looked at earlier, has more than the 2 wires on. So it could be because this has a central sensing pin. If it doesn't see that, it won't power up. I've seen this sort of thing happen where without the original power supply, the laptop will power up but won't charge the battery. Yeah. And we fixed that on this channel, on the previous one, by getting an original power supply. So Andy does have the original power supply for this. So let's try that now and see if that makes any difference. So here is the original supply. He gave it to me, HP branded with the cable. It looks like there's only 2 connections. No, there's an inner metal shield inside here as well, so you can see like ground, and then inside there's like another ring of metal. That'll be the 19 volts, and this is the sense pin in the middle. So let's connect this up. I've disconnected my bench power supply now, and let's see if this makes any difference. Okay, so power on, light comes on, goes off, flashes, comes back on again, and I'm pretty sure we're going to find the same thing with the cycling voltages. Still doing it. I'm just going to try one other thing as well, guys. Something stupid, but it's just occurred to me. Yeah, cycling. You don't suppose this has to be screwed down, do you, to ground this? Because remember, I didn't have a ground on here. What do you think? Okay, let's see. Light comes on. Blinks the same, so no difference. Same problem. So we've eliminated the power supply. I had a quick look. I found a post on Badcaps, somebody asking how you can program the EC. They give 2 options. I actually have both of those available. One of the possibilities is to use this. So this is an RT809 SP programmer. So this will program a lot of EPROMs, but it also will program things like EC chips. I believe this also will program a lot of microcontrollers and such like. So this is an RT809. I've never actually reviewed this, so if you guys are interested, maybe we could play with that sometime. This actually belongs to Detlef. And the other option would be to use this. I've had this for a couple of years or so. This came from Elena Virchinova, lady in Russia, so her husband or partner or some family member, I would say husband because there's an at on here, designed and made this thing. And I got this just after the start of the special military operation, by the way. They had one lying around, asked if I could buy it, and they said yes, but we can't guarantee it will arrive. And a couple of weeks later from Russia it turned up. So these are not easy to find if you guys have never seen one of these before. This is a Virtunoff jig, okay, and this comes with a load of these. So these are like ribbon cables you would normally have on a keyboard, on a laptop, and that's how it programs the EC. So the EC is connected to the keyboard connector. You disconnect the keyboard, you connect one of these ribbons to this, and you can program them. Yeah, so this is an EC programmer. This also will program TCON boards as well. Again, you've never seen this, guys. The reason I've never done really, A, I've never actually really needed to use it yet, and B, they're like rocking course manure, so I believe these are unobtainium. But anyway, that is a Virtunoff jig. Of course, you guys may know exactly where you can get these from, so let us all know. So I have two methods in which I can try to program the EC in case it is corrupted. I believe the VRTIANOFF is the easier way, but we'd have to go down that route and find out down that rabbit hole, okay? But the other problem then, I need firmware, so I need a dump off another one, I would imagine, for a correct model. Yeah. Handy Andy, I'm guessing, does have the back of this. I can probably find out what it is. But time is money. And I said to Andy, okay, in fairness, mate, get another battery. If it still doesn't work with the battery, I can see about programming it. If I can find the firmware, if it all work then, okay? The problem with that, Andy says, usually I order batteries to the Canary Islands, they don't turn up, or I pay a lot of money, and I agree with that. They're not easy to get batteries onto the island. So he says they're cheap in Germany, so he said, well, when somebody's coming over, I usually ask them to bring a few batteries. And that means, at the moment, guys, this is on one side. Unless you guys would be convinced this would work if we program it and we have access to the right firmware. Anyway, I'm sure there's a lot to learn on that video, so I hope you really did enjoy it. Anyway, thank you to Paul for being here on the first half. He's now back in rainy England, okay? And the rest of you, hope the weather's good where you are. This one was just a little epilogue then, guys. So I've been thinking about this overnight, really. This sort of problem with this. So basically, I've fixed a fault, which was a fault. I diagnosed it, I fixed it, and then something else isn't working. And generally speaking, I think a lot of us can say that most things, if they're faulty, they have one fault. And this appears to have more than one. Now the thing is, as I was saying, it could just be because there's no battery on there, therefore it won't power up. I mean, most laptops will power up without a battery, but I wouldn't say all of them will. And I was thinking, well, is there some way to kind of emulate the battery on a laptop, some piece of kit you can use? So you can sort of say, yeah, it works with a battery or some sort of emulator. And I was chatting with Det about this, and I'm not sure that's such a simple thing because, hey, well, there's lots of different laptops, mostly the same voltage, but not all. And they have these various signals on these as well. So it's not a matter of just applying maybe some sort of voltage source, but then it would need to be some sort of current sink as well to emulate the charging. So I thought, well, you know, really that's the wrong way probably to go down that route anyway, because most people fixing laptops are probably in a business that repairs laptops, and they probably just repair laptops, or at least not a whole range of things, which I do. So I'm sure in the shop they will just have a whole stock of batteries because they're a laptop repair shop, yeah, or computer shop, they stock batteries. And they just grab one off the shelf, stick it on there and see if it works. And that's where it falls apart for me, because I don't really have that opportunity. I'm not a dedicated laptop or computer repair business, so I don't have those things in stock. And this is probably why I get to a point like this. So if you're doing laptop repair properly, that's how you should probably be approaching it, yeah? Have this stuff in stock. If you guys got any other suggestions on that, or the ways to work more successfully on these sort of things without reaching these silly little problems, yeah, I could get on to try and flash the EC and whatever, but am I just wasting more time? Don't know. Good question. So down there, guys, discuss, let's hear about it, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.